Are graphing cosecant. Which trig function are you thinking about?
Sine.
Yeah, you're trying to think of sine. Now, I'm going to ignore a lot of the questions until I have this graphed. Just because I feel like if you guys can graph and understand how to graph, then the other questions just kind of fall into place. And let's do this. So, right now what I'm thinking about is negative sine of 1/2 x plus pi, and then it says minus 1. Okay, so before I get going here, I need to take out the b. You guys see the x right here? It has a coefficient. If you take the coefficient out, then you can better see what your h is. Now, if the h wasn't there, it wouldn't matter. You wouldn't need to factor out the b, but I'm going to go ahead and do that. So I have sine 1/2 x, and if I divide pi by 1/2, that would be the same as multiplying it by the reciprocal of 1/2. So what is the reciprocal of 1/2, Stews?
2 pi.
It is 2, and so 2 times pi would be 2 pi. So we have 2 pi right here, and you have our minus 1. Okay, so now we have our b, we have our h, and we have our k, and it looks like the a just has a negative in front of it, which means it's going to be flipped. So I'm going to start with a cheat graph, and I'm going to graph my parent function for sine. And to do that, I'm going to not put any x values down here. This would just be the period, right? Right. Okay, and I'm not going to go up like this. Why am I not going to go up like that first? Because of the negative. You guys see the negative right there? So I'm going to go down. So I'm going to go down like right there. Okay, and then I'm going to graph the ghost of sine, not the whole thing, because I'm not graphing sine, I'm graphing cosecant. Okay, so let's before I put in what cosecant is, let's find the x values and the y values, okay, for my cheat graph, for my parent function. All right, first let's start out with the x values, because those ones usually seem to be the most difficult. Now, if this says plus 2 pi, what is our starting point? It used to be 0, but now it's not 0 because it shifted 2 pi. Which way do we go? To the right or the left? To the left. So this would be negative 2 pi. So if that's negative 2 pi, all right, now I need to know what am I going to count by to make a complete period. We know that the period changed because of this b right there, the 1/2. So I'm going to take the usual period of my parent function, the mother function for sine, and I'm going to divide it by the b, which would then equal 4 pi, because dividing by a fraction is the same as multiplying by the reciprocal, so we get 4 pi. So from here to here, the distance should be 4 pi. Now, some of you guys can do that right off the top of your head. If this is negative 2 pi, what would this one be? 2 pi, right? Because negative 2 pi to 2 pi, that would be 4 pi. If you weren't sure about it, like if you had some kind of fraction thing, which we do not here, you would take the period and you divide it by 4. Why you divide it by 4? Because there's 1, 2, 3, 4 times that we have to add the number to get a total distance of 4. And so when we divide that, we just get pi. So we're just adding pi every time. What is negative pi, 2 pi plus pi? Negative 1 pi. Plus pi, 0 plus pi is pi, and then plus pi is 2 pi, which is what you guys said to begin with. So there's our x values. Let's do our y values now. We have a vertical shift of negative 1, which means we go down 1. So instead of this being the x-axis at 0, it's going to be in negative 1 midline. So that means, what's this top number right here? 0, and what's this bottom number right here? Negative 2. Okay, so now let's do our asymptotes. So I put an asymptote everywhere my ghost function crosses the midline. Remember, this is not the x-axis anymore. And then I just draw off of my minimum values, my extrema, and my maximum values, my extrema, what cosecant would look like. There you go. That's what it looks like. Yay, there's my cheat graph. Now let's see what it looks like on here. Oh, look at this. It goes from negative 2 to 2 pi. Negative 2 pi to 2 pi. Oh, snap. That's what this one goes to. It works so nice. You sound like Mario.
Oh my god.
Hee
Oh my god.
Woohoo! All right. So I got my asymptotes on there. I'm going to graph my points. Oh, snap. Where's my midline? Oh, I can't forget my midline. That messes me up. Where's my midline at? It's at negative. Oh, no. Okay, that's very important. And then we know that at negative pi, we go down to -2. So I'm going to go right here. And then at pi, we're going to go up to 0. And then I'm going to graph my function. Oh, snap. Now let's answer some questions. All right, it says graph it. Okay, I did. All right, next one says identify the period and the phase shift. The period, oh yeah, we found that too. So that's going to be for pi. My phase shift was -2 pi, right? We went left 2 pi, so I'm going to put -2 pi. It says find the range. Ooh, the range. Okay, so you see these, the range is the y, right? The range are the answers to whatever the function is. And so wherever this curve is, that's where the y values would be. We're going to go from -infinity. That's, you know, down here. That's -infinity right there. -infinity to what? To -2. And we are going to include the -2. We don't include -infinity. In fact, we never include infinity. And then we're going to combine that with 0 to positive infinity. So 0 is right here on the y-axis or x-axis. And then we're going to go to positive infinity. So I'm going to say 0 to positive infinity. Infinity gets the parenthesis. The 0 gets the bracket because we have a point right on it. And there's a range. Ooh, so pretty. For parts C and D, answer the questions from 0 to 2 pi. So now we're only considering from here to here. Okay, we don't care about the rest of the graph. Find all the x and y intercepts. Ooh, well, we know there's no y-intercept, right? Because we have an asymptote right there. So for the y-intercept, I'm going to say none or does not exist, whatever you want. And then for the x-intercept, I'm going to say pi. You can say pi, then pi 0, or just x equals pi. However you like. There you go. That's those two answers. And then we have D. D says identify the asymptotes. Remember, we're only from 0 to 2 pi, and we're including 0 and 2 pi. And look, we have an asymptote right at 0 and an asymptote right at 2 pi. So I'm going to say one asymptote is at 0, and the other asymptote is at 2 pi. So there you have it. There's your asymptotes, your x-intercepts. That one's done. Now let's do our last one. For our last one, we have to find the A, the B, the H, and the C. But notice that the way our answer is written, the B is multiplied out into it. So let's kind of write it our way on the other side. Let's go A, secant, and then we'll have our B. Then we have the X. Then we have our minus H, and then we have our K at the end. Okay, so what are all these things going to be? Okay, first, let's figure out the midline up here. Where's my midline at? That one seems pretty simple to find. The middle right there is at 1. So that means our function has to go up 1. Yeah? Yeah. Okay, so we got to put a 1 right here, which would look the same over here. So we got to put a 1, plus 1 right there. Now what are we going to need? We need our period, okay? Now the period, you can find the period a bunch of different ways. I like just going like from here to here, you know, and counting out what that is, or from here to here and counting out what that is. But that right there looks kind of more difficult. Let's see if we can go from here to here. So that'd be 0 right there, and this is a, oh man, what is it? Oh, it tells me what it is. It's pi. So what's my period? It's pi. So if my period is pi, and normally secant's period is 2 pi, what would the B have to be? All right, now if you didn't know, let's just write this out. We'll use some algebra to help us out, shall we? We shall. The period to find secant would be 2 pi divided by B. Now we know what P is. We know that it's pi. The period is pi. So what would the B have to be? And so if I multiply both sides by B, I would get pi B equals 2 pi. And then I would divide both sides by pi, which would give me B equals 2. So there is my B. Okay, I could definitely put 2 right here. I can just transfer that over, so that's 2 right there. Okay, but what about the H? Oh man, the H. Was this shifted? Was the period of secant shifted? Let's think about that for a second. Now, you have to know what the mother function looks like for secant. All right, so if we are looking at secant, all right, and this is just the mother function right here. Secant is cosine, right? It's the reciprocal cosine. So I'm going to draw my cosine just to have my visual going on. And then I know that I would go like this, and like this, and like this. and I would have my asymptotes right there and whatever. Okay, so does it look like this was shifted at all, left or right? No. It looks like at 0 at the starting point, we're right there at the bottom of the screen. Hey, that's the same thing right here, huh? So there's no horizontal shift. And so I would put 0 right here, and 2 times 0 is 0, so that doesn't make any difference, so I just put a 0. Oh, so it looks like we didn't even need that extra stuff, but oh well. Then we have this number out in front. Is the amplitude any different than the mother function? The amplitude, now there's not an amplitude of secant, but we call it the amplitude still. It looks like we just count up 1 for the mother function from the midline. And so how much do we have to count up from the midline for this one? 1. Okay, so it's still 1. So nothing changed. Not difficult. Now what if this was like 2 right here? Like it went up 2, then this would be a 2. What if it wasn't up here? What if it was down here and there was a line like that? Then we would have to have a negative A. But anyways, that's it for that.